This is 4-1's homework assignment in the textbook. We're looking at percentages. And the first couple questions here, it's going to be real straightforward using our is and of formulas to write these out as an equation and solve. So number one, 123%. So first of all, we have to move that 2 decimal places. So one big mistake students make is they always put the decimal in front of the percentage. That's not always true. Now, if you have a 2-digit number, that works. 40% will be 0.4. But if it's a single-digit number like 4%, you can't call it 0.4 because that's 40%. And if it's a 3-digit number or even higher, you can't just throw it to the front. So it always moves 2 spots. So this is going to be 1.23. If you struggle with that, you can always divide. Grab a calculator, think about what a percent is. 123 is being compared to 100. Percents are always out of 100. So divide it, and you're going to get 1.23. So there's your answer there. All right, so 123% of is your indication to multiply. 780 is equals, and then it says what, and that means that's our variable. So we're all set up now. In order to solve this, you're just going to go ahead and do whatever you have to do to solve it. X is already isolated, so you're just going to go ahead and multiply 1.23 times 780. And so my answer is 959.4. Okay, number two, 40%. That's 0.40 or 0.4. You don't need the extra zero at the end here because it's after the decimal, but if you put 0.40, that's fine. Of is times what number? So that's your X. Is 440. Once you write the equation, just isolate X. So this says 0.4 times. So to get rid of it, I'm dividing by 0.4 on both sides. Okay, so 440 divided by 0.4. X equals 1100. Go back, think about it. Does that make sense? 40% of what number is 440? So if I took 40% of 1100, I should get 440. Well, think about what 40% is. 50% is half. So half of 1100. 40% is a little bit less. So does 440 look like a little bit less than half? Sure. Okay, so we know we're pretty much good to go. Number three, what percent? So first of all, it says what percent. So the X is going to go there. Now, this is going to be solved for as a decimal, just like we place decimals into this. But we're solving for the percent. So when we get to our final answer, it's going to be a decimal. We need to convert it back to a percent. So it's going to go 2 spots back to the right. All right, so what percent of means times 4.7 is 0.94. So to solve this, once again, you're isolating X, so dividing by 4.7. So 0.94 divided by 4.7. You get 0.2, so X equals 0.2. So in the equation, the value of X is 0.2, but we're asking for the percent. It's not 0.2%. 0.2 is the decimal that represents what percent. So now we're moving it back, and so this is 20%. We move it 2 spots back to the right, and what you can always do is 0.2 times 100, okay, and there's your 20. Number 4, what number, so X, is equals 62%, move it 2 spots, 0.62. Of is times 980. What number is 62% of 980? So to solve this, I don't have to isolate X. I already have it by itself. So all I got to do here is multiply 0.62 times 980. It's 607.6. Okay, number 5, getting away now from just the basic formulas. Suppose a shirt is on sale for 10% off its original price. So before we even talk about the numbers, 10% off means 10% came off the price. It is not now 10% of the original price. If it was now costing you only 10% of the original price, that means they took 90% off. So we always start at 100%. Whatever the shirt used to be, that's 100%. they're taking 10% off of it. So for letter A, we're not dealing with actual cost here. What percent of the original price do you pay? If they take 10% off, it used to cost whatever, that's 100%. They took off 10%. What percentage are you paying now? You're paying 90%. So now for part B, we're going to use the actual numbers. How much does the customer pay? Not what percent, but how much do you pay? Now it says before tax, meaning you don't have to do an extra calculation with tax. Okay, so don't be confused with that. You don't have to do anything. So we just want to find out if it's 10% off, $23.50, how much do you pay? So I'm going to do it the way that I would do it first, and then I'll show you the opposite way. This is the one that was in your notes that you can do two different ways. So we just talked about how if you take 10% off the price, you pay 90%. So 90% of, so 0.9, 90% of the original price is what you pay. So go ahead, multiply. 90%, 0.9 of $23.50 times $23.50 is $21.15. That's the new price. They took 10% off. That's 90% of the original price. You're paying 90%. If you did this and it got really small, then you know something's wrong, that you're not done at your final answer, because 10% off is not a huge discount. So it should be pretty close to the original price, just a little bit less. And if somehow the price went up, then you know you definitely did something wrong, because this is a discount. Price should go down. So the other way to do this, and probably the most common way, is people take the $23.50 and they multiply it times the 10%. Well, when you do that, you get $2.35. And then the mistake people make is they call that their answer. They say, oh, that's the new price, $2.35. So if it used to cost $23.50 and it only costs $2.35 now, I mean, that's a huge amount of money that came off in terms of a percent, right? It used to cost almost $25. Now it's only $2. That would be 90% off. 90% off, because then you're only paying 10%. So we're not paying 10%. 10% is coming off of the price. So we found out what 10% is. This is the amount coming off the price. So if it used to be $23.50, we are subtracting $2.35 or 10% off of the price, leaving you 90%, which is $21.15. All right, number 6. So suppose a dinner cost D dollars, so they're not going to give you the actual number. Meaning, when we write these out, now we're going to have to write an algebraic expression with a variable. You wish to give a 20% tip. So we know 20% is 0.2. What is the amount of the tip? Now you can't give me an actual dollar amount because you don't know how much it costs. But D here, when they write it out like this, D dollars, D is the variable they want you to use. So not X, not Y, but D represents the amount the dinner costs. You're going to leave 20% of that. 20% of, listen to the words that I'm saying, 20% of times that. Now you don't need the parentheses, so you could just call this 0.2D. That's part A, we're done. 20% of the original price, 20% times the price. Now part B, what's the total cost of the meal with the tip? So the total cost of the meal by itself is D, plus the tip, which we just said is 0.2D. If I add these together, algebraically now, forgetting the context here, they're both like terms. They have the same variable. This has a 1 in front of it. This has a 0.2. So when you put those together, it's 1.2D, and you'll find that that's the answer. Now, how does that relate to the context? Paying for your meal, everything goes back to 100%. If you just paid your meal, you paid 100% of the cost. But you're paying extra. You're paying a tip. And you probably pay tax too. But the tip is an extra 20%. So when I pay the meal and pay the tip, I have now paid more than 100%. I have paid 120%. Well, what's 120% as a decimal? 1.2. Okay, so you're paying 120% of the cost of the meal, more than just the meal, more than 100%, 120%. So when you see the one up front, I need you to think 100%. And then whatever's after it is what's the percent that's been added to it. So it's 1.2D. Okay, number 7. Table's being sold at 40% off. So not 40% of the original price, 40% off the price. So it used to cost 100%. It's 40% off the price, meaning it now costs 60%. So the new cost is 60% of the old cost. So if the price of the table before the sale was $T, so again, they're not giving you the amount. They're going to represent it with a variable, $T, what's the sale price? So the big mistake everybody wants to make is 0.4T and then leave that as their answer. This would be 0.4T right here, the 40% that's coming off the price. But that's not the new price. The new price is 60%. So this would be T. If you want to put a 1 in front of it, that's fine. 100%. Here's the old cost. We're taking 40% off of that. That's going to leave you, if you actually did this in your calculator, 1 minus 0.4 is 0.6T. Now, you don't have to do it this way, showing all of this. You could just think about it. 40% off means I'm paying 60%. So how do I write 60% of the price? Just like this. Of is times when you're talking percents. So 60% of the cost. 60% times the original cost. Number 8. So the store owner buys a television. He adds 45% to get the price the customer pays, right? He's going to charge you more than he paid so he can make money. So the TV sells for $4.99. So in the store, he's already marked it up 45%. What was the price the store owner paid? So what do we not know? We don't know the amount the store owner paid. We're going to call that. But we do know that he takes 45% of that and adds it on. This is 100%. He is going to add 45% to that. So if I combine these, this is 1.45 because there's really a 1 here. What does that represent? That's 145%. The cost you pay is 145% of what he paid. And so we know that, oh, and there's an X on that. We know that after he marked it up, it costs $4.99. So again, this X represents the old price. 145% of means times. The old price is $4.99. So how would I solve this? If I just get this out of here for a second. Isolate your X by dividing by 1.45. So $4.99 divided by 1.45. And we're talking about money here, so we are going to round this off. So when you take a look here, we're going 2 decimal places, dollars and cents, so that rounds up to 14. So we're going to call this $344.14. Okay, number 9. Cost of a camera, including tax, is $215. So this $215 is not the old price of the camera. This is how much you paid with tax added on, meaning that this represents more than 100%. So $215 equals 100%. So let's call that, I can call it a D for digital camera. So if I just left it like this says the cost of the camera is $215. But that's not true. The cost of the camera is less than $215. So the camera plus the tax equals $215. So how do I represent the tax? So it's 8.5%. You got to move that 2 spots to the left to turn it to a decimal. That's 0.085. Now you can't just leave it like that. It has to get multiplied times the actual cost, because otherwise that's just a number like a dollar amount, which would be cents here, 8 cents. That's not what we're talking about. It's the percent of the original price. The tax, 8.5%, is based on the price, right? You pay less tax on a smaller item than you pay on a bigger item. You're going to pay more tax. It's a percent of the price. And remember, when I say of, it means times. Percent of the original cost. So again, 100%. This is the price of the camera. This is the tax. So altogether, when you take the price of the camera plus the tax, you're going to get $215. So of course, we'd simplify this. You put the 1 together with this, which just becomes 1.085. And as you get better at these, you can go straight to this. So we know we're paying more than 100%. We're paying 1.085, which is 108.5%. And once you get all that set up, all you have to do is divide to get the D by itself, and the D again represents the original price. So go ahead and divide that. 215 divided by 1.085. And again, we're rounding this because it's money. So D equals $198.16, rounding up. And you might have done all that and then checked the answer key and been like, oh, I did it wrong. But you didn't do it wrong. This is the price of the camera. What did it ask? It said how much tax was paid on this purchase. So this was the price of the camera. This was the price that you paid after tax. Look at the difference between the two. This one's less, right? Because they added tax onto it and you got this. So the question's asking you how much tax did you pay? Well, that's going to be the difference between these two numbers. So you need to do 215 minus 198.16. That right there is your tax. So 215 minus 198.16. Your tax was $16.84. And again, that number is 8.5% of this. Okay, number 10. So these people buy a car, the amount that they paid was this, including, so this isn't the price of the car, this is more than the price of the car. This is with tax already added in, 8%. So first of all, 8%, you're going to represent 8%, that's 0.08. Now 0.8, be careful, 2 spots. One to get in front of the 8 and another one to move over. If you say 0.8, you're saying 80%, big difference between 80% and 8%. So we have to move it twice. Now, we're not going to use this number and compare it directly to this number. This is an 8% of something else. This is the price after 8% was added to the old price. So the old price, or the actual price of the car, is 100%. They added 8%. So you are going to pay 108%. 100% for the car, 8% for the tax. That's a total of 108%. And you're going to move that decimal over. That's 1.08. So 108% is 1.08. This amount right here is 108% of the original price, which we don't know. So we're not finding 108% of this number. There was a cost. 108% of that cost is this. So divide by 1.08. Well, here, and again, we're talking about money here, so we're rounding, and that's 10 cents. So the answer is $26,158.10. Now make sure that makes sense. Go back. This was the price with tax, this big number. This is a little bit less than it. So does that make sense? Is this the price of the car? Yeah. Here was the price. We added some tax. It went up a little bit. And then that was the price after tax. So if this number didn't make sense, you want to go back and figure out what's going on. All right, after number 10, we're going to 11. So number 11, we're looking at the sales tax over here. So the amount of the tax, not the percentage, the amount of tax was $1.15. The amount of whatever this item was $15.85. We are going to determine the sales tax rate. That's the percent. Okay. This number, $1.15, that's a percentage of this. The tax, 6%, 7%, something like that, of the original price. So we're going to write a sentence out, but algebraically, using all those words. So the 1.15, it is a percentage of this. The percentage we don't know, so that's X. $1.15 is a percentage of means times 1585. Solve it. Get X by itself. So you're going to do $1.15 divided by 1585. Okay, you're going to move that 2 spots, remember, to make it a percent. This is a decimal, 2 spots. So about, because I'm going to round it, 7.2. Now that wherever you leave it off, you're going to have to round it. So you could say 7.3% if you want to round it there. I'm going to go one more number, so that 5 is going to turn to a 6 because of the other 5 right next to it. About 7.26%. Now your book actually said 7.25%. They didn't round it. But we're not too concerned with the rounding. We're concerned about getting the answer here. So we set up an equation and we solved it using is and of. $1.15 is some percentage of 1585. Now, whenever you're trying to find the percent that something is, comparing it to the total, you can forget the equation if you want to. Just set them up in a ratio. This is called a ratio, comparing the two numbers. So $1.15 over 1585, if you divide that, it's going to tell you what percentage it is. Just like if you got, say, a 49 out of 50 on a test, you can divide those, 49 divided by 50, and you can get your percentage, 98%. So you're comparing what you got out of the total, just divide them, and you get that. So you don't have to set up an equation once you fully understand that relationship. All right, number 12. Clearwater High School expects a 4% increase, so it's going to go up. So before we even move forward, whatever it is right now counts as 100%. Whatever the number is, we're at 100%. We're going to increase by 4%. So that means next year we are at 104% of whatever it is right now, or whatever it used to be. So there are 1,850 students enrolled this year. How many students will they gain? So we're not going to calculate how many they're going to be total. We're just counting the gain. So 4% of this is the gain. 4% of means times this. We want to know what's 4% of this, because that's how many students are coming in, 4% more. So 0.04 times 1,850, 74 students. That's part A. Part B, what's the expected enrollment next year? So 74 are going to be added to 1,850, so you could just go ahead and add those numbers together. 1924 would be the number. Now I want to show you something. We increased this by 4%. So that means 104% of 1,850 should equal that number. 1.04 times 1,850, sure enough, equals 1924. So if we can fully understand why that all makes sense, you really have a grasp on these percentages. We found 4% of the student body is 74. We're adding 4% to it. So we went up to 1924. So if we had 100% and we added 4%, that means the new number is 104% of the original, which is 1924. So two different ways to think about it, both giving you the same number. So jumping to number 16, on a math test, there were 8 A's and 12 B's, 10 C's, 2 D's, 0 F's. What percent of the students earned A's? So just like we did up here, we're going to compare a number, which is 8. We're going to compare it to the total amount. So we can say 8 is what percent of the total. So we need the total, so we have to add up. So 8 and 12, that's 20, plus 10 is 30, plus 2 is 32. So we have a total of 32. So 8 divided by 32. I know 8 goes into 32 4 times, right? So as a percent, what goes into 100 4 times? That's 25%. So 8 divided by 32 is 0.25, which is 25%. So 8 out of 32 kids got A's, that's 25% of the class. Now, if you're going to write that as an equation and you didn't jump straight to the division, you would say 8 is what percent of the total, and then you would divide by 32 to get rid of it, and you'd end up dividing 8 by 32, just like we did here, and get 25%. Okay, 17. Consider the following situation. He works at a clothing store. As an employee, he gets a 20% discount, so he pays 20% less. He doesn't pay 20% of the price, 20% less. So if you take 20% off the price, that's what he pays. That's 80%. So he spends this much at the store. Letter A. What was the regular price? So the regular price was more than this. This is 80% of the regular price. We're going to write that out. So first of all, if you need to imagine this, 100% is what a normal customer pays. He gets to take 20% off of that price, and he pays 80%. So $118.50. That number is what? That's 80% of the original price. This is 80% of the original price, which we don't know. If we had the original and multiplied it by 80%, we would get $18.50. That's what he pays. So we're going to divide by 0.8. And notice that the price goes up. If you came up with a number less than this, that wouldn't make sense. He doesn't pay more than the customer. He pays less than the customer. So the actual price here is $148.13 when we round it. So that's part A. Part B now. Suppose the student answers part A in the manner shown below. Show why the student's answer is not correct. So let's see. This person took that dollar amount that he paid and they multiplied it by 120%. So why did they do that? Well, I think it's 20% off, so we tried to put 20% back onto it. So they took 120% of this. Now the number went up, right? So that kind of makes sense, but that number is different than this. So why doesn't this work compared to this? So over here, we were relating the percentage, the 80%, to the original price. Here, we are multiplying times the 118.50. We're relating the percent to this. So just think about tax again. If you buy a big screen TV and you also buy a piece of candy, they're both going to get taxed at the same percent, 6%, 7%. But which one do you pay more tax on? Well, the bigger number, but it's still 6%. But 6% of the cost of the TV is a lot more than 6% of the cost of the candy. So taking 20% of this number is different than if you took 20% of this number. Okay, this is a bigger number. 20% of this is more than 20% of this. So when we take 120% of 118.50, what we're actually doing is adding 20% of this number onto it. But the original price, which we now know was $148.13, 20% of that number came off to get us to here. So how do we put that in words? The actual price is 20% off the original, not 20% of 118.50. All right, number 18. The DVD player originally cost $150. So that's the old price. That's the 100%. It's on sale now for $72.50. So it went down. What is the percent of the discount? Rounded to the nearest tenth of a percent. So this is going to be a decimal. We're going to round it. So this is what it's on sale for now. So a couple ways you could do it. You could compare these two numbers, much like we did here with division, and you'll get a percent. But this is the percent paid, not the percent of the discount. So when you divide this and this, you'll get a percentage that we can use, but it's not the final answer. That's the percent that you paid. So you'd have to think backwards and say, what was the percent that came off the price? That's the percent of discount. So that's one thing you could do. So let's do it that way once. It's not the way I would recommend, but I want you to see how this all ties together. So $72.50 compared to the $150. When I divide this, I find out what percent this is of the original cost. So 0.48 and then a bunch of threes. So about 48%. But that's not the discount. The discount wasn't 48%. You paid 48%. So think about it. If you had 100% and they took off a certain percent, you're paying now 48%. So what's that number? What was the discount? 52%. So that's the correct answer, 52%. And we got to round it with the right decimals and stuff, but about 52%. You paid 48%. That means 52% came off. So how do we get there differently? So first thing you could do is figure out, well, if it costs $150 and now it's on sale for this much, how much money came off the price? What was the discount? So we do 150 minus 72.50. And that's 77.50. So this number, that's the discount. Not how much you paid, that's the discount. That's how much came off the price. So we want to know, if that's the discount, what percentage does this represent? This is how much came off, what percent came off. So you again would compare 77.50 to 150, divide those. And there, you do your little handy dandy rounding, is the 52%. That rounds up to 52%. So we've got 0.51666. So this is the percent of discount. We're going to move this 2 spots. So it is 51 point. Now that tells you how to round it. Nearest tenth of a percent. Tenth is one number after the decimal place. So we are going to put one number here. It's a 6, but the other 6 rounds it up to a 7. And therefore that's our answer. So let's say we had done it this way. We would have this rounded to 48.3%. You paid 48.3%. If you take 100 minus 48.3, you end up with 51.7. Okay, so 2 different ways to get to the same answer. Both are just fine.